So let's talk about the trigonometric substitution. So we need the trigonometric substitution in the cases where we need to integrate some functions which are given in the square root. Okay? So for example, I know how to take the integration, the derivative of a squared minus x squared, probably, right? Can you take its derivative with respect to the x? So this is 1 over 2 square root of a squared minus x squared, right? Multiply it to the derivative of the a squared minus x squared with respect to the x, which is equal to what? 2 minus 2x, right? So the answer will be x divided to the square root of a squared minus x squared. Okay? Yeah? Using the chain rule. Right? Because derivative of the square root of x is equal to the 1 over 2 square root of x. Right? So square root of x and its derivative is 1 over 2 square root of x. And square root of some function of the x is 1 over 2, the same function from the square root, multiplied to the derivative of this function, which is like a derivative of the a squared is 0, and derivative of the minus tx is, derivative of the minus x squared is minus tx. Because a is a constant. Okay. So even though this might be difficult, but we can do this, right? At least. So what is the integration of the a squared minus x squared? What is the integration of the a squared minus x squared dx? This is what I want. So I know how to find its derivative, but now let's discuss how to find its integration. Okay. So what is the idea? So what kind of ideas do you have? So we need to substitute the x with something in order to get rid of the square root, right? So if I would have just a function without a square root, it would be better, right? So then I need to substitute the x here in this case as the a multiplied to the sine of u, for example, right? And now I see that if I substitute the x was the a squared, so sorry, basically, a squared minus x squared would be in this case as a squared minus a squared multiplied to the sine square of u, right? So it will eliminate this square root. For example, let's substitute the x squared here, okay? So if x squared is equal to the a multiplied to the sine of u, what is the a squared minus x squared? A squared minus a squared sine square of u, right? From the square root. If you take out the a squared from the brackets, you will have simply a multiplied to the 1 minus sine square of u, right? What is the sine square of u? It's cosine square of u. If you take the square root, what you will have? A multiplied to the cosine of u, right? You see? So we eliminated the square root, right? But additionally, we need to calculate dx as well, right? So if the x is equal to the a multiplied to the sine of u, u in our case is the variable, right? And a is the constant. What is the dx? It's like take the derivative and multiply this to the du, right? What is the derivative of the a multiplied to the sine of u? A multiplied to the cosine of u multiplied to the du. Okay? So this is equal to integration of a multiplied to the cosine of u, right? Because this is the square root of a squared minus x squared, multiplied to the dx, which is a multiplied to the cosine of u du, right? So we've got integration of the a squared multiplied to the integration of the cosine square of u du, right? And how to take the integration of the cosine square? We need to decrease its power, right? We need to write this as a squared multiplied to the integration of the 1 plus cosine of tu divided to the 2. And its antiderivative will be equal to the a squared multiplied to the integration of the 1, sorry. Integration of the 1 over t is 1 over 2 u plus 1 over 4 sine of 2u plus some constant. Right? So at the first glance, so even though we could get rid of the square root, we still need to do some work. Okay? So let's do one more exercise. Another exercise. So could you please find the integration of the 9 minus x squared divided to the x squared with respect to the x? This is just a substitution. Someone just figured out that if they do this, they can get rid of the square root. Okay? So you just need to learn. So if you have the integration in the form square root of a squared minus x squared, where a is some constant, then you just need to use this substitution. Okay? So x is equal to the a multiplied to the sine of u. Okay? So in our case, in the last exercise, not in the last exercise of the lecture, just here, right? So 9 minus x squared from the square root divided to the x squared multiplied to the dx. So I need to get rid of this square root, right? So this is in the form some constant in the square minus x squared, right? So what kind of substitution we need to use? So x should be equal to 3 multiplied to the sine of u, right? Why 3? Because if I put the 3 here as a substitution, and if I substitute the x squared here with this substitution, this becomes 9 multiplied to the sine square, right? Then I can take out the 9 from the square root. If it would be, for example, 8, then you cannot do anything, right? For example, if you just decide to choose x to be equal to the 4 sine of u, if you substitute your 9 minus x squared square root with the x, what you will have? You will have 9 minus 16 sine square of u. Can you get rid of the square root? You cannot do this, right? That's the problem. So this number here should be also 9, right? So that is why this number here should be also 3. Okay? So you need to choose the 3 so that this number in front of the sign and this number, this constant, should be the same. If you have 8, then here you need to write square root of 8. Right? If you have here 14, you have to write here square root of 14, right? So that when you square this x, the constants will be the same. Okay? So if you take out the 9 from the square root, what you will have? 3, right? 3 multiplied to the square root of 1 minus sine square of u. Then it is 3 multiplied to the cosine of u. Right? This is not the end of the story, so we need to do a lot of work still in order to find the integration. Okay? So since we decide to substitute 9 minus x squared with the u, you have to substitute all other x's as well with the u. Okay? And it doesn't work when you substitute half of the integration with the u, and you will leave the others as they are. So the 9 minus x squared will be equal to the 3 multiplied to the cosine of u divided to, what is the x squared? 9 multiplied to the sine square of u, right? Multiplied, what is the dx? 3 multiplied to the cosine of u du. Right? Okay. So all the constants will be eliminated, right? This one and this one and this one. And we'll have sine square of u divided to the cosine square of u du. Okay? Okay. Sorry. Cosine square of u divided to the sine square of u du. Is it better than the previous one? Okay, it is better, but still difficult, right? I need to figure out how to take its integration, right? So let me write this as integration of 1 minus (1 over sine square of x minus 1). Okay, let's write this like this. Okay, so can I do this? Yes. So because if you now take the common denominator, it will be 1 minus sine square of x, which is cosine square of x. U, right? Sorry. Can we write it like this? Yes? Okay. So how to integrate this? Easily, right? So the integration of the 1 over sine square of u is given in the integration table. This is equal to the minus cotangent of u. Minus the integration of the 1 du is easy. It will be simply u. Okay? So this is cotangent of the u minus u plus the constant. Okay?
How do you expect us to do it in the exam?
You just need to do this at home at least once. Okay? But this is not the end of the story, so we need to use the different other trigonometric substitution for the other cases. Okay? For example, if you have this kind of integration, what you need to do, what kind of substitution you need to use here for the x in order to get rid of the square root? You cannot use the sine anymore, or you cannot use the cosine anymore, right? Okay, tangent. Okay. I thought you will think more longer. So a multiplied to the tangent of here, right? Now, if you substitute this, you will have a square plus a square tangent square of here, right? So a square can be taken out from the integration. So this is a multiplied to the square root of 1 plus tangent square of u is equal to a multiplied to okay, so this is 1 over cosine of u, right? Because 1 plus tangent square. So 1 plus tangent square is sine square of u divided to the cosine square of u. If you give the common denominator, it will be 1 over cosine of u, right? You can get rid of the square root, okay? So let's do one exercise. Cosine of u, because you took the square root, right? You took the square root. Sorry. Okay? So let's do an example. So integration of the 1 divided to the x squared multiplied to x squared plus 4 dx. So all the problems in the integration are difficult. This is because this is the inverse problem, right? All the inverse problems are difficult. Okay, so let's do the substitution right here. So we need to use the substitution. X should be equal to tangent of u, right? So what is dx? Is t multiplied to the 1 over cosine square of u, right? Derivative of the tangent is 1 over cosine square, and derivative of the cotangent is minus 1 over sine square, okay? So let me substitute everything here. So this is 1 over t tangent square of u multiplied to, sorry, not 2, 4 here, right? Multiplied to, what I will have from the brackets? I will have t multiplied to the 1 over cosine of u multiplied to t multiplied to 1 over cosine square of u du, right? Let's substitute. Let's try to simplify everything. So let me write, so this t and t will be cancelled. Let me write 1 over tangent square of u is the cotangent, right? Or simply cosine square of u divided to the sine square of u, okay? Multiplied to the 1 over cosine of u, it becomes simply cosine of u, right? Multiplied to 1 over cosine square of u du. Okay? And I can simplify this one, or let me simplify this one and this one, right? And I'm going to have cosine of u divided to the sine square of u du, which is doable, right? I mean, actually, this is easier than in the previous cases. So how to integrate this function? Do you have any ideas? Huh? Substitution method, right? So what kind of substitution I need to do? So we need to substitute the sine square of u as some new variable v, right? Then I need to take the derivative from the both sides. Oops, sorry. Just the sine of u. Just the sine of u becomes v. And then I need to take the derivative from the both sides. What is the derivative from the left-hand side? Is cosine of u du. What is the derivative in the right-hand side? dv. Okay? So is it possible to substitute everything inside this integration here? Right? So cosine of u du is equal to what? To the dv. Right? And sine square of u is equal to what? V squared. Right? So basically, you can write as v in the power of minus 2, right? Plus 1 divided to the minus 2 plus 1. So this is equal to the minus v in the power of minus 1, minus 1 over v. Do you remember what was the v? It was sine of u, right? It is minus 1 over sine of u. What was the u? This is 1 over 2, arctangent of the x squared, right? You can resubstitute everything back at the end. Okay? This is called the trigonometric substitution. Now, so I told you in the beginning that if I would like to apply the integration for further applications, I need to know some techniques, right? So let's apply the integration now and apply the techniques which we just learned to find the areas. So let's say we're given an ellipse. What's the equation? X squared over a squared plus y squared over b squared is equal to the 1. Okay? Do you remember what was the ellipse? Or do you know what is the ellipse? It is a circle with two radiuses, okay? Was the horizontal radius and was the vertical radius. Okay? So the horizontal radius is given with the A, okay? And the vertical radius will be given with the B. So basically this distance is equal to the B, and this distance is equal to the A, okay? Then you need to put the ellipse here. Okay? This is the ellipse, good, with two radiuses. So this distance is A, and this distance is B, okay? And the equation is like this. If the horizontal radius and the vertical radius are the same, right? What kind of equation you will have? For example, if A is equal to the B, you will have the equation of exactly the circle, right? It will be x squared plus a squared, y squared is equal to the a squared. Right? If the a is equal to the b, you will have x squared over a squared plus y squared over a squared is equal to the 1. If you multiply everything to the a squared, you will have x squared plus y squared is equal to the a squared. Okay? This is an equation of the ellipse. I would like to find this area. Okay? So how we can find the areas? We can find the areas using the integration, right? So let's find this area, only the upper part, okay? So the equation of the upper part will be, so I need to find this y from here, okay? So let me find the y. So the y squared over b squared is equal to the 1 minus x squared over a squared, right? Or basically a squared minus x squared divided as a squared, right? So what is the y squared? Is b squared over a squared multiplied to a squared minus x squared. So what is the y? Is plus minus b over a multiplied to the square root of a squared minus x squared. Right? So if I find the area of the upper part, upper half of this ellipse, I can find the area of the overall ellipse by just multiplying this to the 2, right? If I multiply this area dashed area to the 2, I can find the area of the overall ellipse, right? So this function on the upper half, is equal to this function with the plus sign, okay? On the lower part, you will have this function with the minus sign. So I need to integrate b over a square root of a squared minus x squared with respect to the x, where x changes from where to where? If this distance is a, how the x changes? What is this point? Minus a to the a, from minus a to the a. Okay? You see, so in order to find the areas of the circles, ellipses, we need to apply the trigonometric integration, substitution. Okay? And we can find this integration easily by just applying the substitution, where x is equal to the a minus sine of